And today we have quite a few on the call, and we are going to cover with a few items with Gerald, and we're covering Sonic on the DPU progress today. So we have the NVIDIA team, Liat, Alexander, Marian, etc. Anyone else who'd like to be introduced as we hop into slide 3. And from Microsoft, Gerald, me, James, and maybe Prince will be joining. Um, so the agenda for today is we would like to have NVIDIA present some information and give a demo with Sonic on the DPU. And Gerald will hop in and we'll talk first about why Sonic and what we're working on there. We were hoping that would take about 8 minutes, and then we'll do a demo with NVIDIA. And we've allotted 20 to 30 minutes for that. Plus, I assume there'll be some Q&A at the end of that. So any questions on the agenda today, or should we get started?
Christina, hi. Maybe after NVIDIA does there, we'll talk just about automating the pipeline a little bit. And I think it'll actually be a nice segue after they present.
Yeah, hopefully we can save some time for that. So that would be
If
great.
not, we can kick that down the road a week.
Okay, great. And so moving on, I'd like to hand over control to the NVIDIA team. We have Alexander speaking and presenting right now. Would you like to take control, Alexander?
Are we not going to talk about why Sonic?
Oh yeah, I'm sorry, Gerald. I forgot your part. Okay, Gerald, yeah, go ahead. So it's Gerald first.
We do get a lot of questions there, especially with new people coming in. And this is a Dash community, so if you don't know what Dash means, it means disaggregated API for Sonic hosts. So that should give you a clue that this is based on Sonic. One of the reasons we chose Sonic is exactly the same reason we created Sonic in the first place. We used to have in the cloud multiple operating systems. Often the CLI might look the same, but their operations were different, their monitoring was different, their OSs were different. And it took a lot of cost and people to manage them because they really were different. And our software systems actually had to handle all the little variances and then handle all the security. So what Sonic gave the switch will give the DPU is the ability for a major cloud or even a large enterprise to incorporate this technology from multiple suppliers without undergoing those high costs of operations and management. And that's very important. And some people will say, oh, I don't want to do that because it's hard. But you know what? When they don't get the business down the road, then they complain they didn't get the business. And there's a high cost of bringing in something with a different OS. So a long time ago, we standardized on Debian, and we saw all the arguments for like why they can't bring their own operating system. And that was settled a long time ago. But one of the things beyond just the operational benefits and the cost to us to onboard is security. And with security, you have to understand that we have hundreds of thousands of switches, and even with this device, we're going to have tens of thousands of these devices in our network. And every time an operating system has some kind of patch, some kind of security issue, we have to, in a very short period of time, prove to government audit organizations that we've gone around and patched all those security holes. And so imagine having, 3 different suppliers, but they're all over the world, and they will be, and they're in different places and different quantities. And now we have to monitor like the 3 different operating systems plus the Sonic operating system and go and select which boxes, need to be upgraded or patched or whatever. That's pretty cumbersome. And we spent a lot of time on security and patching and making sure that our customers are safe. And we can't actually handle that many operating systems. It takes a fairly large team already to go and do this work. And it's audited by the government. And quite frankly, we have a no tolerance to security issues in our network. And so keeping with one operating system allows us to just go and basically repatch the entire fleet all at once when necessary. And we have tools in place to do that. But having multiple different types of operating system, where you have Debian on the switch and then different operating system on DPUs and different for every vendor and different different vintages of the operating system, across, multiple implementations, that's not sustainable in the cloud. And that's why Sonic has been successful. One of the reasons it's been successful in the cloud. And then we have a lot of government clouds, and Sonic switches is in all of the government clouds and is widely accepted by the government today. And by building these smart switches, on top of the Sonic operating system and using this, most of the Sonic operations, we basically almost get a buy to deploy these in government clouds. And those are worth a lot of money. And quite frankly, all the large cloud providers do serve the government and know what I'm talking about. That's very difficult to qualify anything you do in the cloud. So the other thing is that when we started Sonic, besides all the operational and security benefits, we started Sonic based on the fact that, it was going to be from day one containerized. And we have a lot of infrastructure on being able to maintain containers, swap containers without hits to the underlying infrastructure. And that includes things like BGP. We can swap out the BGP. If we don't like Quagga, we can swap it out for something else. And that ability is really golden to us. And so over time, Sonic developed and matured and added more and more containers along the way. And we want to take advantage of that, but we also want to take advantage of our test infrastructure that we have for Sonic. And yes, it needs to be updated. And, thank you, Keysight and others who are working on, the QA part of this for doing that and working on that. But they have something to build upon. And this is invaluable because, we want these switches in our network GA, mid next year. We want them proliferated thousands in every quarter through our network. We can't afford to take huge delays on building infrastructure and trying to rebuild container management and all those types of things. And these are the things that we get, which are very mature now from Sonic along the way, which is why in this group here, we call it disaggregated APIs for Sonic host, because it is based on the Sonic infrastructure. Underneath, as we know, we don't, just like SCI, underneath the covers, even though you're running the same operating system, et cetera, the actual data path software is separate for each vendor. We're not insisting on any approach, people or other, but the overarching, management of these units is going to be based on Sonic. And you will see today that not only is it achievable, but Mellanox is going to show you exactly what they've done so far, which is pretty significant. And you'll see more demos along the way. And all of this knowledge, of course, will be shared with the community as we go along. This is open source, so anything that is on the Sonic side of things is actually open. So any container that is developed for Dash will be open, and so you get a lot of benefit from that. So that's just my little pitch for why Sonic. But like I say, Dash means disaggregate APIs for Sonic hosts, and this group is based on Sonic infrastructure, and we decided that a long time ago at the beginning. And so we're not going back on that. So I hope that's clear to the people who have questions on that.
Thanks, Gerald. Very well said. I just want to add one more thing is actually this is not only within Microsoft. This actually when we talk to many of the Sonic adopters in the industry, they resonate, right? And they resonate that the solution needs to be generic so that it can be long-term. It's not a one-time, one technology with one company's engagement, but they can apply it for much longer term. So for this technology that enable acceleration using different different technologies in general and using a standard API standard way, so enable it to go much longer and being adopted by many other companies and users who are interested in this. Yeah, thanks. What you said is very well said.
Yeah.
Okay, so let's get on to the excitement for the day before getting on to Q&A. I think Mellanox is going to show us something that they've achieved over the last little while.
Right. So we'll have Alexander present and share.
Yeah, 1 second. So let me know when
Thank
you
you.
can see my screen.
We can see.
Okay, good. Good. So, hello everyone. My name is Alexander, and I'm leading development of Dbusonic on NVIDIA side. And today I'm going to present what we have, what we achieved so far. Here on the diagram, we have a Dbusonic architecture. This diagram represents our current status of implementation, and it covers only underlying API implementation so far. So as you can see, it is very similar to what Switch Sonic has, but with a reduced number of components that is going to be supported. In a diagram, we have the highlighting components with two colors. The blue one is for the existing components that we took from Sonic, and as it is working without any changes. So as you can see, we have BGP, LDP, SNMP, telemetry containers, which exactly the same as in vanilla, let's say vanilla Sonic. We have SWSS container, which right now is the same as in vanilla Sonic, but with reduced amount of features. We have database container, and the only two components so far that are modified in order to run Dbusonic on our Bluefield modules is syncd container and pman. So in syncd container, we have a syncd application, which is going without changes and is exactly the same as in Switch Sonic. And here we have SAI implementation or integration with DPU SAI implementation, and our NASA SDK, which is actually controlling our DPU. So in order to be able to run, so we added our implementation of SAI. We integrated our SDK into syncd container and all the underlying drivers that are controlling DPU. And
what does NASA SDK mean? Is there is that an acronym for something?
NVIDIA SDN application.
Yeah,
it's our SDK. No problem. It's our let's say acronyms for our DPU SDK. So the SAI layer, which is the same SAI API that will be used in Sonic Vanilla plus the Dash API, and the SAI implementation, which is NVIDIA SAI implementation, and all the APIs that are defined are implemented on top of an SDK. and the NASA is the SDK, let's say, implementation, which is integrated into SyncD. So if you are going to have like another DPU which is not based on NVIDIA, the main work that the vendors need to do, they will need to create their own SyncD container. Part of that, as Alexander mentioned, is the it's the generic part, and part of that is the vendor specific. And which, if you will go to the switch part, you will see the same. You will see that the same SyncD, which is the common layer, is available on all vendors. And then each specific vendor has its own SI implementation, and the lower level, which is usually an SDK, it is what each vendor provides.
Yeah, thank you for that. Actually, can you say the NASA acronym a little slower? I didn't quite. NVIDIA something SI application, but I didn't get.
It's NVIDIA SDN. Yeah, it's the NVIDIA SDN or Azure SDN application. I will send you exactly the name.
Okay, thanks. You can put it in chat. Thanks.
And in Daemon container, we have all the Daemon running that are vendor independent, and we have our own implementation of Python plugins, which do communication with platform drivers. So all the rest parts are exactly the same as in vanilla or Switch Sonic. So do you have any questions on this slide?
That's good.
If not, let's move to implementation details a little bit. So for Dbusonic, we have a reduced amount of components. The list of components that need to be supported by DPU is defined in an HLD document that Prince presented some time ago. And here we can see that in DPU, we are running 8 containers. On the 8 containers, we have telemetry, SNMP, LLDP, or Cajun, which is SWSS container, SyncD, BGP, Daemon, and database. And so all the other components that Sonic includes, or Vanilla Sonic has, not part of DPU work that we are doing right now. And we can also check the list of features that should be supported by Dbusonic. And here we can see that, for example, router advertiser container, TeamD, and DHCP relay containers are disabled. So now let's talk about memory consumption of Sonic. So we did some measurements, and what we wanted to understand is how much the Sonic consumes, Sonic image consumes RAM memory. So we did this investigation in the stages. So here we can see on the slide, we can see how much memory is used by Sonic base OS. It's in the case when no Docker containers are running and Docker Daemon is disabled itself. So we can see that Docker Daemon is not running, and free command shows us that base Sonic OS consumes only 159 megabytes. This base OS includes all the kernel drivers that is required for DPU, for our Bluefield DPU to be able to run. So it's base Debian plus additional kernel drivers that are required for DPU. So on the next slide, we have Debian OS memory usage plus Docker daemon. Sorry, this slide shows the memory usage of another NVIDIA-specific Debian image that we are running on DPU. As you can see here, we have like in use 721 megabytes, which shows that it's actually much more than base OS of base Debian OS in Sonic consumes. It's maybe not very accurate comparison, but it shows that actually Sonic doesn't add a lot of extra memory usage. On the next slide, we can see how much memory is consumed by Debian OS plus Docker daemon that is running, and we can see that Docker daemon is consuming around 50 megabytes when it's just running without any containers in the background. And actually, next slide shows how much memory is consumed by all the containers that are required and running inside Dbusonic. So we can see here 8 containers, and all the containers consumes 1.3 gigabytes of memory, including memory that is consumed by Debian and Docker daemon. So we can calculate that containers itself with all the applications running inside consumes around 1.1 gigabyte. And we can also take a look to Docker stats. This command provides the resources usage by Docker containers, and we can see how much memory is used by each container. And it actually depends on what container, how many applications containers are running inside, but the usage is quite similar and between all the containers. Okay, and now we can take a look to a short demo that I recorded with actually Sonic running on our Bluefield module, and to take a look to some operations with interfaces. So let's start. Here we can see the result of show platform summary command. So we have our platform, our SKU, ASIC counts, serial number of module, model number, and we can also see that here we have like a new field which is called switch type, and switch type is set to DPU. Based on that field, we will do a customization of Sonic initialization flow, and will run and apply only needed components and configuration. We can see all
quick question.
Okay.
Just a quick question on this memory consumption. So what was the initial configuration? Did you have anything on the DPU, or is it like totally blank, in other words?
No, there is no extra configuration applied. It's only the default configuration of the interfaces, and that's it.
Okay. And then I don't know whether you're going to show it in the demo that, once you begin to have all those, either the tables populated or the flows programmed and so forth, right?
Mm-hmm.
So how does this actually increase and so forth, right? So
this is currently not the scope of the demo.
Okay.
What we are showing in the demo right now is the interface and the platform parts, which is derived from the existing CLI, but the implementation of both the platform API and the, let's say, interface SI API's implementation. The rest will come on later, as mentioned by Gerald. We will have probably few demos in the next few months. So right now there is no flows that are configured on the dash and not on the SWSS, which are related to the overlay. So it's only all the interfaces that are, and here we have only two, the interfaces and all what is derived from an interface configuration.
Okay, got it. Thanks.
So you won't find the memory consumption that you look for. I think that once the dash HLD will be, the SWSS dash HLD will be completed, then we can come up with a memory consumption of what we believe the schema will take. But it is out of the scope for this demo.
Okay, thanks.
Okay, so let's continue. Next we have a list of features that are enabled for Dbusonic. And here we can see that we have a syncd container, and we can see a list of applications that are running inside the container, and we have a syncd, and we have actually NASA application. So next we have a result of work of show interface status command. We can see two interfaces, lanes configuration for the interfaces, speed, MTU. We can see that admin opera status is up, admin status is up, and we can also see the SFP type here. So let's now shut down the interface and verify its status. So the interface is going down. Now let's do the same with the second one. So we can see that both interfaces now are down, and we can bring them up again. Verify their status. They are in up state again now, and what we can do additionally, we can try to set MTU on the interfaces and check that MTU is actually changed. So yeah, and in additionally, we can verify that how Daemon is working, and we can try to execute show interface transceiver presence command. So this command shows the presence of SFPs, and we can also read EEPROM of each interface. And yeah, we will get actual information from interface EEPROM. So yeah, that's it from my side. Do you have any questions on that?
See, Liad, you mentioned in the architecture, right? Unlike the regular Sonic, the flow programming is very important for DPU, right? I don't see anything, the flow handler and stuff like that are mentioned in the architecture. Did we design that part yet, or the current scope is to bring up the interfaces and stuff like that?
It is correct. The current status is that we had to do changes in order to have Sonic running on top of ARM, and then Sonic running on top of Bluefield, and then making the interface configuration fully aligned with what Sonic expects you from a user interface. Now, there are like additional phases which are still in progress. The next one is to show that we have like traffic, a BGP peering, that it is working. And later on, based on dash HLD, you will see that how the overlay or how the VNet to VNet flow will be integrated into Sonic. It is like possible that you can kind of still use the like all the in the syncd, you have everything in order to control the DPU. So you still can control it even if it's not Sonic, just for like testing or basic interoperability. But later, all of the flows that you are talking about them, then you are then will be available through the Dash API, through the SWSS, through the syncd as yet another API or whatever will be the way to configure the DPU itself.
Right. I mean, in terms of if you keep the kernel to handle flows, it's really not going to scale anything, right? So I believe other DPU vendors using VPP and other open source tools in order to handle flows better, right? So I hope we consider the scalability.
What do you mean by handle flows exactly?
Because there is no LPM and other stuff, right? I mean, support present in the DPU. So we need to basically take every flow to the CPU to resolve ARP and other stuffs, and then you program the flow directly, right? So in order to do that AB operation, right, the kernel is not really going to help there.
No, we don't expect the kernel to handle the SDN packet processing. This is not the expectation.
So this DPU, what you are saying is in the context of Dash, or it's a general DPU that we are trying to say here?
We are trying to integrate with SideDash, right? So we need a DPU. You're starting with a DPU that can implement SideDash. Now, how the DPU implemented that, whether it is software or hardware, is per vendor. Some vendor can do it in the hardware, some need some CPU assistant, but it is actually underneath, right? It's underneath side, not above, so it's not part of Sonic.
Okay, the flow programming is not really clear. Yeah, I think when we go there, maybe we'll discuss better. Yeah.
Yeah, there's many other meetings where we talk about flow process,
right,
and many documents you can read. We have a lot of documents that if you go read them, then come to other meetings where we talk about the overlay and the behavioral models. Those are, when we talk about the behavioral model, we're talking about the overlay. So you can come to those meetings and make sure you read the documentation that is in place when you come to those meetings. This is ongoing. I think what NVIDIA showed is amazing. It's a great start. They ported, Sonic to their DPU. The infrastructure is there. They built some customized containers and have shown the community how this can be done. And they did it in fairly short period of time. In parallel, NVIDIA, of course, is just like others working on the overlay behavioral models and the HLD. And as those do complete, I'm sure you're going to see a very coolant demo. And you know, the thing that you should understand is that at least functionally, we have this working in our network in pre-Dash. So it's not like we have to guess whether this might work. It does work. This is the public version of what we're trying to put out there that, you know, will be shared with the entire community, and the community come together and see all of what we learned over the last year or two and standardize on it and be able to produce things, you know, products that other clouds can use easily. But whether it works or not is not the question. We know it works. This is about the standardization or in the open community about how to do this in such a way that we can have multiple vendors providing the same functionality, same operations, the same security, etc., so that the consumption of these technologies can be cloud-wide and even large enterprises. So that's what we're doing. Those are different meetings. So come to the behavioral model meeting. That's where we talk about overlay a lot. But I think what NVIDIA's done is really, really a great start to this journey. And, you know, hopefully by the end of the summer, we'll have like some really cool demos of overlay and things of that nature, but it will take a little bit of time.
Yeah, I concur completely, Gerald. You know, NVIDIA folks, great work, guys. A lot of progress has been made, and then this is great. So just a you know, quick question on so far.
Hanif, I think John has his hand up for first there. Yeah.
Oh, okay. Sorry, I'll
okay.
just make sure my put my hand up before. Okay.
It's okay.
Yeah, I just wanted to understand. It's a great demo, but I want to understand like is anything that's being demoed today, like, is there like a plan to upstream any of this? Like what has been done by NVIDIA that's like applicable to be like upstreamed? And I'm just thinking in terms of like, is there like a new kind of target, like build image for Dash, or I just want to know if like what would be upstream that like would be leverageable by. Yeah.
Eventually the plan is to have it upstream, since it's still like, as you saw, it's a very, let's say, major milestone, but still not exactly related to the overlay itself. We will do that once we have like a concrete working environment for Dash, and then we will do that. It's not just NVIDIA. It is a shared like effort that will be done with other contributors to this community. And the purpose eventually is to have it as part of the Sonic vanilla.
Okay. Thank you.
Go ahead, Hanif.
Yeah. So thanks, Christina. So question for NVIDIA folks in terms of, you know, this all, the entire exercise that you guys have done. So what were the learnings, right? Do you want to share like in the summary of what did we learn out of this exercise?
Learn in terms of like development process, or learn in general about Sonic and DPU?
Yeah, the learning in general, the Sonic and the DPU, right? Of course, there were some objectives that you wanted to achieve by bringing this one in, so that it you know, moving forward, it just really you know, validates certain assumptions you made or certain things that you wanted to carry it out. I just wanted to just see, you know, what, if you have any insights on that.
Okay, so we are working in parallel with the, let's say, how the Dash API will be translated, or what is the software architecture of the SWSS Dash in order to support the API. I can say that one of the things that we are, let's say, in the process we are learning is what exactly is needed from the very huge list of features and a very huge list of SI APIs that are defined on the switch, what they are needed and what is the priority for them. I can say that there is a very, let's say, there is a process already, which is, I'm not sure if it's closed, or if it's almost done or not, but it's a very, let's say, in a good direction to be closed, is the HLD for the SWSS. And I think that that one will be shed more light about how the behavioral model that is defined on the side dash in this community will be integrated into the Sonic as that. Of course, we need to take into consideration the amount of like flows and configuration, and this is something that it's been also under discussion. So I think that the major part that we can say for now, which I will put the execution aside of the architecture, and I believe that Matti and Marian can tell you a little bit more about the architecture side. But from the execution side, it was mostly in making and understanding what is needed, what need to be excluded in a way that we can exclude it later on a Sonic vanilla upstream, and how to, let's say, integrate a working solution on a specific, let's say, specific vendor. The nice thing is that Sonic is already available with all of that. So if you want just another board or another ASIC, there is a bunch of files and a very nice wiki that can describe. And if you are familiar with Sonic, it is likely to be easier for you than for someone which was not yet familiar with that. So mostly the work was to gather all the requirements and start the execution in levels. And the basic stuff is to make sure that the NOS part, which is not vendor specific or which is not yet relevant to the ASIC itself, is kicking, working, and fully functional.
Yeah, no, I actually wanted to touch on something else basically, but good, these are good insights. So thanks, Riyad, for sharing that. So as Gerald started out saying that Sonic today is available, right? It runs on switches, and so far the use case was that Sonic always ran on external CPU, right? And then now we are getting into the model where Sonic is running on a CPU which is actually embedded in the DPU, right? And then this is where essentially is a huge difference for people who are basically coming in. And then the reason why I say the huge difference is not from the perspective of that whether or not we can run Sonic on the DPU, but the fact that it's embedded in the DPU ASIC, so to speak. That brings in some sort of like a requirement part of it to say that, hey, if we are going to say that, okay, we require a DPU with a certain amount of CPU and an embedded memory in it, what are these, right? So far, Sonic was not really defining, at least as a requirement or as its specification, that, hey, you must have your, the CPUs by this much of, capability, or memory with this much of, the size, right? However, now that we are getting into the mode where it's actually embedded into the DPU, right? The CPU as well as the memory, we do need to, as a community, need to come out that, what's the minimum requirement there are from the CPU perspective versus, also the memory perspective. That is the one that we should come out as through this exercise of really, running this thing and say, what is it really? To start with base configuration plus, when you scale up and how it is going to be. So this is what I was basically looking at, and perhaps as a community, we should strive for that.
And that's
We
an
were going
excellent
to talk
segue.
about that today, but we won't. I fully understand what you're asking for, and we have started that work, and we were going to talk about today, but we knew that we would run out of time. So we'll talk about it another day. But one of the exercises, that you saw with the NVIDIA demo is that they're measuring memory and CPU utilization, et cetera. And over time, we'll get a better picture. That is the task. But we also have some preliminary work that we've done to estimate as well in parallel to what we think is going to happen, and we'll just over time, hopefully those things will converge. But that should come out of this working group for sure, the minimal requirements and what to expect from, CPU and memory utilization, because we all understand that that is shared with the DPU's ability to do overlay. And so it's important. And that's what this work group will actually, in the end, have to highlight and put out there in documentation to make it clear. And also we will optimize this as we go along, but it's a good point. But we won't have time today to actually get into all the other details of memory utilization and CPU utilization, but we'll definitely get to what you're talking about over time.
Yeah, okay, thanks, Gerald. Yeah, and also there is a use case part, right? Like smart switch versus appliance versus NIC, where in some cases you have an external CPU versus the one where you don't, right? There are some differentiation that we will also touch upon that, but I get your point. But thank you. Thanks a lot.
Thank you.
Yeah.
Looks
One
like
comment.
Lisa has a question. Oh, go ahead, Shin.
Oh, go ahead. That someone has hands up before me.
Oh, it was Lisa Wen has her hand up and Venkat Malinga, but we want to get yours in too.
Yeah,
So go ahead,
thanks.
Lisa.
Sure. Thank you, Christina. Yeah. So far, we have Sonic running on x86. So this is the first time that NVIDIA team have shown that we have Sonic running on ARM. Great demos. Thanks for showing it. My question is that a smooth transition from an x86 into an ARM, or there is a low-level platform? Not platform, infrastructure change that you have to go through to get it working?
If I'm not mistaken, and Alexander, please correct me, there was some infra. There is some infra in the Sonic for ARM, not exactly the same. I think it's ARM F, if I'm not mistaken, but the transition was not that, let's say, I think that there will be switches based on ARM as well as for DPU. Yeah. The main difference is that our switches are based on x86, while the DPU is ARM64. So we had to do the transition and making sure that everything is in place, including the build server. What I can tell you that cross compilation is much, much, much slower. So if you want to bring up an equipment which is ARM64, it's better that you will have a server that it's a native one, native compilation and not a cross compilation, because then it takes much more time.
Got it. Thank you.
But that's like a general comment, whether you are coming from the DPU or from the switch.
Thanks, Liat.
Got it. Thank you. Is that the plan that you will share? Oh, sorry, Christina.
Oh, go ahead.
Yeah, is that the plan that you will eventually share on of this platform infrastructure piece of software also? The change that you make?
Yes, that's my what I mentioned is that eventually everything will go upstream. I don't have right now an ETA when. It depends on the progress and as well as the let's say the completion of the SWSS. So it is a work in progress. Once it will be, let's say, I won't say stable, but we will feel that this is the time to upstream. We will do that. No, we believe in the upstream way.
Got it. Thank you. Yeah.
Thanks, everyone, and thanks for showing Alexander. And Shin had a comment.
Oh, my comment is very small that for Liat, and I believe you might plan to do that for the DPU side, right? Once we standard this, we should also take it to the site community, the broader site community, so that we talk there and get built into the site releases. Like, I mean, not from the Dash side only, but for the general site community. Is my understanding right?
I think that what you are asking is to take the side dash into the side community. That's what you are referring?
Yeah. When it's mature. Yeah.
Okay. Yeah, I think that it's clear.
Yeah. Okay, thanks. Yeah.
Great. So, oh, Venkat. So we have 7 minutes left unless we want to take a break for our next meeting. Venkat, go ahead.
Yeah. So this is undoubtedly, great demo, great starting point to enable Sonic on the DPU. So my point more on, I know what you are doing in the, dash, basically using the SDN controller and doing stuff. But when it comes to, non-SDN controller, if you want to control everything from the DPU, like flow handling and everything, I think we need because the DPU has different capabilities. Not every DPU has same capability. We cannot generalize it, and we need to come up with differences and see how better we can handle it in the syncd container and stuff like that. I think when we do, I see a lot of unknowns here. From dash perspective, things are contained, but when we enable Sonic on the DPU in general, there are a lot of other things we need to consider. So for the dash perspective, I see the other Sonic architecture as well and how things are being handled from Sonic side. But when we enable DPU in general for Sonic, then we need to really consider other things. And if we are not sure on those things, I think we need to start putting things for the discussion.
I think you, I said before, come to the behavioral model meetings where we discuss such things. That this is not the meeting for that. There's other test infrastructure and behavioral model meetings where we discuss what the DPU requirements are from an overlay point of view, which is what DPUs specialize in. So I think, definitely you should come to those meetings, and there's a lot of work being done in those meetings, and there's a lot of contributors to those meetings. So it's not like Mellanox only, as Liat said. There's many contributors to the behavioral model for the overlay and to the test harness that's being created right now. So those meetings are more appropriate to discuss like the DPU capabilities and stuff like that.
So Gerald, when you say, the DPU that here we are talking about is meant only for the overlay, not for other traffic, because when I see this DPU Sonic architecture, I assume it's for everything, like a regular switch, all the use cases, tar replacement, a lot of things we can handle, right? So
you can, and we've listed a lot of use cases already in the documentation. Okay. And today we actually run this, the equivalent of this on DPUs sit on a server. There's multiple of them that sit on a server. And now we're building switches where we put DPUs on switches, and you could even run DPUs in hosts. So there's lots of applications that are even beyond, the switch. But again, those are things that we discuss more in the behavioral model and test harness groups.
Thanks. So we have 4 minutes left, and Hanif had one more. Yeah, go ahead, Hanif.
Sorry,
and then we'll be.
So
please go.
I think this is probably for Gerald and maybe others also. But initially, when the entire vision was shown, it seems like we wanted to run Sonic on a DPU, irrespective of whether whatever be the use cases, such as either appliance or NIC or smart switch. In appliance and NIC, it makes sense, right? That hey, there is no external CPU. But when it comes to smart switch, there is an external CPU. But does it make sense to really run multiple instances of Sonic on the external CPU?
I think I covered that. We're not going to have anything in our network, and I'm sure other clouds won't either, that we can support operationally or from a security point of view. And you can't ignore the fact that DPUs are running operating systems. They are themselves running operating systems, and they need to be managed, and they need to be secure, and they need to be, have a lot of common functions that we don't want to duplicate across multiple different operating systems. It's not sustainable. It's not what any large customer would want. It takes millions of dollars to support, an operating system and the tools around it. And so from the beginning, we decided that a switch, will have the same, operating system as Sonic, whether it be DPU or whether it be on the switch, for those reasons and more. So we're not going to go back on that. It's not like really a debatable item. We can't support having multiple operating systems choice being made by, you know, suppliers, and then also multiple vintages of operating systems from those suppliers. It's not.
Yes, no, sorry, Gerald, my question was not that. Yeah, I think, sorry, I wasn't able to basically complete my question, but it's not that we want to run a different, or I'm suggesting running a different OS on a DPU. My thing is that there is a little bit of a different architecture, even in HLD, that is on the community right now for a smart switch, whereby, you know, there are certain different components are split between running on external CPU versus running on a DPU and so forth, right? So my thing is that it's still a little different of an architecture when it comes to an appliance or a box which has an external CPU versus the one that doesn't, right? And
so one thing about Sonic that you're probably, maybe we can update the HLDs, is that where the containers actually run, you know, where even like the dash container runs, right now we have it, you know, shown as running on the switch. We can move them to the DPUs. If that turns out to be the more efficient way, we can do that. So what we're really talking about is where certain containers run. And depending on how we draw or what we learn, we might run containers slightly differently than what is shown today. We'll find out over time. If we find that running, say, the dash container on the switch doesn't scale as well as we thought, then we'll move it to the, you know, we'll move it to the DPUs and do things slightly differently. But be open on that one. I don't think the actual final implementation has been done, and where the containers, you know, land in the end will, it's going to depend on our experiences. So don't use the HLD now as like the gospel, since we're at the kind of at the beginning of a cycle. It may be updated over time as we learn.
Gerald and team, I'm going to call time. It's 10. I don't know if everyone has another meeting. I know I do. But maybe we can pick up some discussion next week. Is that okay with everyone?
Yeah, that sounds good.
Okay.
Thanks.
Okay. And I'm sorry if I didn't get to all the questions. I'm going to stop the recording. And I just want to say thank you so much to